Hello, welcome to the COB channel. This is part of Management Science. Today, we are going to discuss PERT and CPM. So first, what is the purpose of PERT and CPM? They are two popular quantitative analysis techniques to help plan, schedule, monitor, and control projects. Now, let's get to know what PERT means. PERT stands for Program Evaluation and Review Technique. It uses three time estimates to develop a probabilistic estimate of completion time. On the other hand, CPM stands for Critical Path Method, and it is more deterministic technique as compared to PERT. So now, let us get to know about the 6 steps on how to perform PERT and CPM. First, we define the project and all its significant activities or tasks. Next, we develop the relationship among the activities and decide which activity must precede the other. After, we draw the network connecting all of the activities, followed by assigning time and/or cost estimates to each activity. After which, we need to compute the longest time path through the network, which is called the critical path. Finally, we use the network to help plan, schedule, monitor, and control the project. Furthermore, we must take note that the critical path is important since any delay in these activities can delay the completion of the project. So here is an example. General Foundry Incorporation has long been trying to avoid the expenses of installing air pollution control equipment. The local environmental protection group has recently given the company 16 weeks to install a complex air filter system on its main smokestack. General Foundry was warned that it will be forced to close unless the device is installed in the allocated period. They want to make sure that installation of filtering system progresses smoothly and on time. Here, we have the activity and its description, and the immediate predecessors, or which activity should be done first before the next activity can be acted upon. For now, let us learn how to draw the network to understand the sequence better. There are two common techniques for drawing PERT networks. The first one is activity on node or AON, where the node represents the activity. The other is activity on arc, where the arcs are used to represent the activities. The AON approach is easier and more commonly found in software packages, and this is what we will use in this lesson. Here is an example. One node represents the start of the project, one node for the end of the project, and the other nodes for each of the activities, which are represented by letters of the alphabet as shown in the picture. In addition, the arcs or arrows are used to show the predecessors of each activity. So now, we should do on the AON for General Foundry. Let us go back to the table shown earlier to review the immediate predecessors and connect the network. Now, this is the network model for General Foundry. Don't forget that we should always begin with start and finish with end. Now that we know how to draw the network, let us get to know more about activity times. In some situations, activity times are known with certainty. The CPM assigns just one time estimate to each activity, and this is used to find the critical path. Moreover, many projects have uncertainty about activity times. PERT employs a probability distribution based on 3 time estimates for each activity. A weighted average of these estimates is used for the time estimate and is used to determine the critical path. It also often assumes time estimates follow a beta probability distribution. Here are the 3 time estimates. First, we have the optimistic time. It is a time an activity will take place if everything goes as well as possible. There should be only a small probability, say 1 out of 100%, of this occurring. Next, we have the pessimistic time, or the time an activity would take assuming very unfavorable conditions. There should only be a small probability that the activity will really take this long. Lastly is the most likely time. It is the most realistic time estimate to complete the activity. Now, let us recall what we studied in statistics, which is the normal distribution, to understand the beta distribution with the three time estimates. At the left side, we have the optimistic time. In the middle, we have the most likely time. And at the right side, we have the pessimistic time. To find the expected activity time, the beta distribution weights the estimates as follows. Add a 4 times m and b together all over 6. To compute the dispersion or variance of activity completion time, we use the formula b minus a all over 6, then raised to the exponent of the whole side to 2. Here, we have the estimated time for general Foundry. Now, let's compute for the expected time and variance. So here, we have the answer by following the equations showed earlier. Now that we have the expected time, we must find the critical path. The critical path is the longest path throughout the network. To find the critical path, we need to determine the following quantities for each activity in the network. First, we have the earliest start time. It is the earliest time an activity can begin without violation of immediate predecessor requirements. Next, we have the earliest finish time. It is the earliest time at which an activity can end. We also have the latest start time. It is the latest time an activity can begin without delaying the entire project. And the latest finish time. It is the latest time an activity can end without delaying the entire project. Here, we have the layout on how to input the time activities and their respective start and end time in the node. First, we write the activity. Beside it, the activity time. At the bottom of the activity, we write the earliest start on the left side and the earliest finish on the right side. On the bottom of the earliest start, we write the latest start, and at the bottom of the earliest finish, we write the latest finish. To compute for the earliest finish time, we add the earliest start time and the expected activity time. For the earliest start computation, it is the largest of the earliest finish times of immediate predecessors. Take note that for early start, we begin with the node closest to the start. For the latest start time, it is computed by latest finish time minus expected activity time. To get the latest finish time, it is the smallest of the latest start times of the following activities. Take note that for late finish, we start with the node closest to the end. In this image, we see the network layout for General Foundry example. First, let us try to compute the earliest start and earliest finish of activity A and B. For the start node, we set the activity time to 0, so both A and B has the earliest time start of 0. The earliest finish for A is 2, since 0 plus 2 is 2. On the other hand, for B, it is 3 since 0 plus 3 is 3. Now we do the same for the remaining activities. Now let us do the latest finish and latest start. The activity time for the end node is the largest finish time of its predecessor. For this example, it is 15 from activity H. Thus, the latest finish time is 15 for activity H. For the latest start time, it is 13 since it is computed as the latest finish minus the activity time. So 15 minus 2 is equal to 13. The same thing is done for the rest of the activities. Once the earliest start, late start, earliest finish, and latest finish have been determined, it is a simple matter to find the amount of slack time for each activity. Slack is computed as late start minus early start or late finish minus early finish. In this image, we have computed slack for each activity. If slack is equal to 0, it is considered to be part of the critical path because any delay in the critical path can cause a delay in the entire completion of the project. Based on the results, A, C, E, G, and H are critical activities. Again, critical activities are those that are in the critical path. Moreover, industrial managers call this as a boundary timetable. So in the image, we get a better visualization of the activities in the critical path, meaning a delay in activities A, C, E, G, or H may cause the whole project completion to delay. Thus, managers should make sure that activities on these paths are done quickly and to be on schedule. That ends for this episode. We hope you learned something about PERT and CPM in this video. Thank you for watching and stay tuned at COB channel for more videos. If you have any comments, questions, concerns, or feedback, just put it in the comment section below. Give us a thumbs up and subscribe.